Transformations to congruence. If you take a look in your book on page 225, you'll notice this definition: transformations in a plane move or change a figure to produce a new figure. A rigid motion is the transformation that preserves length, angle, measure, and area. A rigid motion is also called isometry. So the idea with an isometry, I've defined this for you guys before, is that the length, angle, measure, and area all stay the same. There's three such transformations in which this happens. Those are translations, reflections, and rotations. They're also down here below: translations, reflections, and rotations. Let's look at a few examples. It says describe the transformation or transformations you can use to move the blue figure onto the red figure. Well, one thing that looks like this is a translation to the right and then a rotation clockwise 90 degrees. So a translation to the right and then a rotation of 90 degrees. Additionally, over here we might have a translation and a reflection over this line. If we knew what this line was specifically, like the x-axis or the line x equals 2 or something like that, we would want to definitely say this. If we knew how many units we were translating, we would have to mention those as well. It says tell whether the two figures in the quilt are congruent or not congruent. Those are your two choices. If they are congruent, describe the transformation or transformations you can use to move from figure A to figure B. You have to look carefully at quilts. My mom is a quilt maker, and sometimes they're pretty exact, and sometimes, they're off a little bit. So you got to watch those carefully. It looks like A. Let's see, it has 1 block, and then 3 blocks, and then 5 blocks. We have 1 block, 3 blocks, and 5 blocks. The only difference I see, besides color and that it's kind of a reflection, so the orientation, is that these blocks are a little bit thinner when we go right to left here than these here. I would say this is not a transformation. If these were the same size as these blocks, you could say that it was either a reflection over, say, a line right here, a vertical line, or you might say that it's a rotation of 180 degrees, maybe about this point right here. This thing would just rotate around and start pointing to the right. If we look at A and B, we have sort of what it looks like a maple leaf. And I think if we pick a point right here, this would be a rotation, probably about a 90-degree rotation. Maybe the point is right about here, where we're actually rotating. You see that these stems could come down. Stems could come down. We could have a nice 90-degree rotation clockwise. Let's look at some more examples. Explain why figure A and figure B are not congruent using transformations. Well, I think if we were to reflect this A over, then we could probably try to rotate it down a little bit. It looks like this portion right here is a little bit longer than the portion that we started with over here. So if we look at this again, first thing we do is we might try to translate this guy over here, and then when we reflect this guy down, this part really gets stretched out. Here's a good picture of what I'm talking about. So in order for this to be a congruent, the shape that we started with has to be the same down here. As it says in the down here, the figures are not congruent. That's because even though some of the corresponding sides are congruent, the corresponding angles are not all congruent. So again, this angle much different than this angle that we have right here. It says figure A is a little bit more challenging here. Figure A is moved onto figure C by a translation, followed by a reflection, and then a rotation. Pauline says the figures A and C are incongruent or not congruent. Ayo says that the combination of transformations is an isometry. Is Pauline or Ayo correct? Explain. Well, for me, I do believe this is a translation. Then we do reflect over this line, whatever that line might be called, and it looks like we're just going to rotate this, I don't know, somewhere like maybe 50, 60, I have no idea how many degrees, some sort of rotation. Because this is a translation, reflection, and rotation, each one of those are a form of rigid transformations, so those would turn out to be an isometry. So I would say that Ayo is correct. Pauline better get her head together, else she's not going to do well on that next test. So keep that in mind, Pauline. Let's look at our next example. A phrase, I don't know if that's how you pronounce this, a phrase pattern is a pattern that repeats in one direction. Oh, that's charming. Designs for wallpaper using phrase patterns are shown below. Describe a series of rigid motions that transform the shaded part in order to create the pattern. So it's kind of a real life idea here, is that they have some wacky design. They could basically use some computer in order to say, well, I want this shape over here, then here, then here, and here, to repeat in order to make wallpaper. You might also see this in tiling for floors, or pretty much anything that has patterns that repeat. For me, I might say that this is a reflection. If we were to draw a vertical line right here, in order to get this shape, we could probably just translate this guy over there. We could probably have a reflection over maybe a line right here to get the first, second, third, fourth figure. We can continue translating here, and maybe have some sort of, if we really wanted to, we could rotate this guy about 180 degrees if we picked a point right about here. The same kind of concept happens with number 5, that the first one is going to be some sort of reflection probably. The second one might be a reflection at a slightly different point, or line I mean. So maybe right here we'll reflect over to get this guy. From there we'll translate again. We could translate another time, and maybe if we picked a point in here, we could either reflect over this line, or we could probably do some sort of rotation and reflection if we really wanted to. Kind of an interesting idea. Just to kind of show how some of this might be used in real life. The last one I'm going to leave you with, it says quadrilateral A is rotated onto quadrilateral B. I totally believe that. It's definitely a rotation. Explain how you could use a combination of two reflections to achieve the same result as the single rotation. So it says that A is a rotation and it turns into B, maybe about a point somewhere in here. But there's also another way to do this, that we could use two reflections. I want you guys to think about that. If you want, you can talk to me about it at a later time. Our topic today was simply looking at transformations and how they relate to congruence. Your assignment is below.